Okay, 9.5 special products. Let me give you a little disclaimer right off the bat. These special products that we're going to look at today are all shortcuts. I'm not a big proponent, meaning in favor. I'm not in favor of shortcuts early on in your understanding. I'm in favor of them later on down the road after you know what's going on. Here's one of the problems with shortcuts. You have to remember when you can use them. And then you have to remember them as well. And usually where students get in trouble is they misappropriate the shortcut. Okay, do you guys know what it means to misappropriate funds? They are funds that are for something else and you use them. Misappropriation of funds. If you misappropriate the shortcut, in other words, you use it in a place where you can't use the shortcut, then you're in trouble. Perfect example is, you don't need to write this, is the exponent rule, x to the a to the b equals x to the a times b. A bunch of you guys misappropriated that shortcut when you had a problem like this, and you thought that was x squared plus 4, and it's not. You misappropriated the shortcut. You applied the rule in a situation where you can't apply the rule. And the difference was monomial, polynomial, binomial. And therefore you misappropriated it. So, I say all that to say this. The things we're going to look at today, you can definitely do longhand and not worry about the shortcut. And I'm not so worried about the shortcut right now. We're going to get a few things next chapter when we factor that we'll need to learn, which are these shortcuts in reverse. We'll learn them then well. So I'm saying all that to say this. If you don't quite get these shortcuts down, it's okay. You can just do them the long way, and actually the long way is a little bit safer. Okay? So I know that's clear as mud, but hopefully you understood what I'm saying. All right, here's the first one. The square of a sum. The square of a sum. So what does that mean? There's the square, and there's the sum. The square of a sum. So you're adding things and then squaring what you're adding. The square of a sum. Kirsten, question?
On homework, do you want us to use these shortcuts?
The homework's design is for you to use the shortcut, yes. Okay, so let's do the first one. Let's just go longhand. So if you saw this problem, hopefully you definitely wouldn't misappropriate the exponent rule, and you'll say this is this situation, right? So this is an a plus b times the quantity a plus b, right? And we already know how to multiply two polynomials. We're going to distribute. So we all know a times a is a squared. As we continue to distribute the front a, we do a times b is a positive ab. Now watch, when I distribute this positive b times an a, I'm going to put the variables in order, right? So you get ba, but that's an ab, right? And in the back, a positive b times a positive p is a positive b squared. Grand total. A squared, I'm going to use my green right here, plus two of them, right? One of them plus one of them is two of them, plus 2 A, and I'm going to use my black here, B. And then plus, and then finish in black, B squared. And that is the pattern. So that is the pattern. So the idea is this multiplies out to this, to an a squared, use your exact color, plus 2 ab plus the b squared. And with the pattern, we can do other things. But again, I mean, you got to remember the pattern. And it really only saves you one little thing. But you can use it if you want to. So let's do B here. So when I look at B, I'm looking at the pattern in the box. Okay? So a squared would be a what squared, looking at specific problem B? Somebody raise their hand. What's the front thing going to be? What's the front term going to be? Kirsten? Okay, that is correct. I'm going to not go ahead here. Let me use blue. I'm not going to skip a step. But in this case, the a is the 2x, and therefore it's the 2x squared. Kirsten already multiplied it out and said 4x squared, right? Because the front thing is a 2x, so the front a is a 2x. Okay, the next thing we're supposed to have is a positive 2 times, somebody tell me times what? Everybody thinking now, try to look at the pattern and apply the pattern to our current situation. So it would be a plus 2 times what? Kaylin? Not quite. Go for it, John. Not quite. You're looking right here, right? We already have the plus 2. You're looking right here. All right? Okay. Back. So what's next? Adam?
X1.
Nope. Not XY. What's Josh? Yeah. What's the A? Oops. I was saying A as I was writing. What's the A? A 2X. What's the back? The Y is the B is the Y. The A is the 2X and the B is the Y. Look, if it'll help you, A, B. All right? Does that help you? A, B. Therefore, what's the back going to be? It's going to be the B, which is a Y, and it's going to be squared, right? Now we got to finish it off, though. Remember, a 2x squared is a 2x times a 2x, or a 2 squared x squared, which is 4x squared, right? And we can all multiply a 2 times a 2x times a y. That's a positive 4xy and plus y squared. And we use the quote-unquote shortcut, which isn't so short, and it's confusing, isn't it? And I'm telling you, if you just did 2x plus y times 2x plus y, you'd have been at 4x squared plus 4xy plus y squared, probably even faster. But they do want you to begin to try to learn these patterns. Again, if I were you doing a quiz or test and I gave you that problem, I'd be very leery about using the shortcut because I don't want to make a mistake. I just multiply it out. I'm thinking maybe you're going to take a few more seconds. It may actually be shorter just to multiply it out. All right, so let's now again try to do it in example C. Why don't you try C? I'm going to pause. All right, so everybody had, say it out loud on 3, 1, 2, 3. All right, heard some of the correct answer. 25n squared plus 20np plus 4p squared. Just applying the pattern. Because the a is a 5n and the b is a 2p. So it's 5n squared plus 2 times 5n times 2p plus 2p squared. Everybody okay with that? How many got that right? Oh, oh man, that's scary. All right, you might not want to use the pattern if you're on a quiz or a test, because that's certainly, I mean, did you have any problem writing this first line? I mean, the A is a 5N and the B is a 2B. You put the A squared plus the 2A times B plus the B squared. Surely you got 25N squared out of that. I would hope. Come on. 5N times 5N. 25N squared. Again, you're not applying the exponent properly if you're not getting that. 2 times 5 is 10 times 2 is 20. So you got the 20 there. And 2p squared. 2 squared p squared is 4p squared. All right. Whatever. It is what it is. This one is called the square of a difference. The square of a difference. Again, notice a quantity is squared and the things are being subtracted, right? Subtraction, difference, and they're being squared. Now, I will be honest with you, this pattern is a key pattern in factoring. This pattern is a key pattern in factoring, the opposite direction. So in this pattern, we go the opposite way. I'll mention that in a minute, but this one is very, very similar. If you look at the square of a sum, you got a green plus sign. Here you got a red minus sign. That's it. It's the only difference. So would it surprise anybody if you start off with a squared? Hopefully it doesn't surprise anybody that you end up with positive b squared. The only question is, what is the middle term of this trinomial? Anybody want to take a stab at it? Come on, you can only be wrong. Who cares? A bunch of people are wrong. What's the middle? John?
AB.
Not quite, but at least you tried. Connor?
Minus.
It is minus 2ab, and I'll do the minus 2 in red. This one ends up minus 2ab. When it's positive, it's plus 2ab. When it's minus 2ab. And again, if you were to multiply that completely out longhand, you would get a squared minus 2ab plus b squared. Next chapter, you don't need to write this. Next chapter, we're going to learn to take this and factor it, unmultiply it back into this. And that's really, really, really important. And we'll actually, instead of calling it the square of a difference, we'll call it the difference of two squares. Okay? But that's a whole nother story. But that's where we'll head next chapter. Again, the pattern is a shortcut. If you can't handle a shortcut, do it longhand. All right, so why don't you do B and C? All right, I'm going to pause. Go ahead and do B and C. Everybody look up here, otherwise you're going to be wrong. Pretty much since pre-algebra, I taught you to keep a sign with its number, yes? Okay, or variable. However, the pattern takes care of all the signs. The pattern does that. The negative 2 in the middle takes care of the sign. The plus sign before the b squared takes care of the sign. Therefore, again, the A is just the front, whatever's in the front, and the B is the back. All right, with that information, go ahead and do those two. Squared, right? 9a squared minus 6a plus 4. And, whoa, did I miss something? Wait a minute. See, be careful. Shortcuts can mess you up. Minus 12a. Man. All right? Minus 2 times 3 times 2 plus 4. And the second one is 25x squared minus 20xy plus 4y squared. How many got both of those? How many got at least one of the two? At least one of the two. That would be all of you guys as well. At least one of the two. All right, questions. Questions. The A is a 3A in the first one, and the B is a 2. And the A is a 5X in the first one, and the B is a 2Y. Josh. Say again. For B. This is a, you talking about this middle part?
No, the original.
Okay, what about it? Right here?
Yes.
Okay, what about it?
Yes.
So ask your question again.
Where does it go?
Where does the negative go? Okay, so that was the part I was trying to tell you in the beginning. When I said that this negative is taken care of, I'm in the wrong place here. Oh, brother. All right, this negative here, Josh, is taken care of by the negative 2. It's also taken care of later on by the plus sign. So the pattern takes care of that negative right there in the pattern. So again, if you were to multiply it out longhand, you'd see that that's indeed how it ends up. So that minus sign is taken care of by the pattern. Kaylin. Say again, you figured it out? Okay. Any other questions on those two? Okay, so 3 is a difference of 2 squares. It's the other way. And this is multiplying, introduce a term to you guys, conjugates. All right, we're not doing English. We're not conjugating verbs. A conjugate is the binomial of another binomial with the different sign in the middle. So, for example, if you look here, here's a binomial. Its conjugate will be the same binomial, except the middle sign will be the opposite. So the left one is A plus B. Its conjugate is A minus B. When you multiply conjugates, you are multiplying and ending up with the difference of 2 squares. And so this pattern ends up this way. The front one squared minus the back one squared. And again, the pattern takes care of the signs. The A is the A and the B is the B. The A is not a positive A and the B a negative B. The negative sign in the middle in red takes care of the positives and negatives. The A is the A and the B is the B. So if we were to do this one, and this is a simplistic example, it would be the A squared, which in this case is an X, a minus sign, and the B squared, which is a Y, a difference of 2 squares. You see, that's where you end up. You have 2 things being squared. It's a difference of 2 squares. So again, next chapter, we're going to take this and factor it into that. We're going to go backwards. All right. What happened to my page? I guess I got rid of it when I was getting rid of stuff. So let me pull out my page here. Brother. Okay, so I did that pattern again because we're on a new page and I want you to be able to see it. So can you apply that pattern to B? Pretty simplistic. What is the A in this case? The A is an X and it gets squared. We use a minus sign. We have conjugates. And the back is going to be the B, which is a 3 squared. And we wouldn't leave that as a 3 squared. Again, please understand the pattern takes care of whether that's positive or minus. It's just a 3 times a 3 for a 9. And that's an x squared minus 9. So the front one squared minus the back one squared is what you're doing. Front one squared minus the back one squared. See if you can do that with C.